By the year 2200, humans won't just look at the night sky. We'll live inside parts of it. But not the way movies promise. No galaxy tourism. No instant warp jumps. The real future is more interesting because it has limits. So here's the real question. Which worlds can humans realistically reach 2200 and actually survive on? Not just a flag in a photo, I mean bases, cities, supply chains, and people who don't come back. To reach a world and stay there, you need 4 things. 1. Distance you can cross repeatedly. 2. Radiation protection for humans. 3. Local resources, especially water and fuel ingredients. 4. A reason to keep going back. Science, industry, or survival. If a place fails even one of those, it might still be explored, but mostly by robots. Now let's start with the guaranteed human worlds. By 2200, the most realistic human world might not be a planet at all. It's near-Earth space, orbital stations, rotating habitats, shipyards. Why? Because it's close. It's where you build the infrastructure that makes everything else possible. And then there's the moon. The moon is reachable with short travel times and frequent supply runs. It has something priceless: ice in permanently shadowed craters, meaning water, oxygen, and rocket fuel ingredients. By 2200, a realistic moon future looks like cities inside lava tubes or buried habitats for radiation shielding, mining and manufacturing, telescope arrays, and fuel depots for deeper missions. The moon becomes the dockyard of the solar system, and once you have a dockyard, you go for the big prize, Mars. If the moon is the dockyard, Mars is the first true frontier society. Mars is far enough to force independence, but close enough to still matter. By 2200, humans can realistically reach Mars often. And we could realistically build long-term cities there. But here's what Mars life probably isn't. Not open-air streets under a blue sky. Mars life is more likely sealed habitats, underground districts, pressurized greenhouse farms, advanced power systems, and strict recycling, because your life depends on it. Mars is survivable, but it demands discipline, and that's exactly why it becomes important. It's the first place where humans learn to live without Earth's safety net. Now here's the twist. By 2200, humans may not only settle planets, we may settle rocks. Asteroids are brutal for human comfort, but perfect for resources. So instead of towns, asteroid life looks like small crew habitats, heavy robotics, processing stations, and shipping lanes of materials back to space factories. Asteroids become the solar system's industrial backbone. Now what about the maybe worlds? This is where science fiction gets loud. But realism gets picky. Venus's surface is a nightmare. But high in the atmosphere, where pressure and temperature are more manageable, you could imagine floating research platforms. By 2200, Venus cloud bases are possible, but likely small and specialized. Europa is icy with an ocean underneath. Fascinating. But radiation is intense. Titan has thick atmosphere and strange chemistry. Also fascinating, also hard. By 2200, humans might visit these places, but most living there is probably robot-first exploration, occasional human crews in hardened bases, short stays, high-risk, high-reward science. So yes, reachable, but not easily livable at scale. And what about other star systems? The honest answer? By 2200, we might send probes that far. But sending large numbers of humans? That's a different level of energy, shielding, and time. Unless a breakthrough happens, interstellar human travel by 2200 is likely rare, experimental, and extreme. So the realistic human map of 2200 looks like this. Near-Earth space becomes home base. The moon becomes the dockyard and fuel hub. Mars becomes the first true off-Earth society. Asteroids become the industrial frontier. Venus clouds, Europa, and Titan become high-risk science outposts. Other stars remain the dream for now. And the biggest twist? By 2200, the most important world might not be a planet at all, but the space between them.